All right, so as promised, these are some videos with the questions in the homework 16. This is number 27. For this problem, you are given that the number of a particular fish in thousands, X years after 1971. What does this mean? This means that when X is 0, that represents the year 1971. If X is 1, that represents 1 year after 1971, so that's 1972. And the function that models this is this f of x. F of x equals 236 times 0.881 to the x power. So by now you should know that if this number right here, a, is less than 1, then we have a exponential decrease. And then this number, 236, is the initial amount you start with. So for this situation, we can have a graph like this, where x is the numbers of years after 1971 on the x-axis, and on the y-axis we have our f of x, which just gives you the number of fish in thousands. Okay, so this is in thousands, and the equation is an exponential decrease. So it starts at 236 and then it decreases. And our goal is to find the year. So for what x, so x equals what? The year when the number of these fish reached 95,000. So if it started with 236, I'm interested to find when it's 95. So let's say 95 is right here. So when we learn about logarithms in section 5.4, we'll learn how to do this algebraically. But for now, you're only expected to know how to find it graphically. So graphically, I'm interested to see when this function, exponential function, is equal to 95,000. So if I draw a horizontal line, I'm interested to find for what x is the y 95,000. So to do this, we are going to put it in our calculator. So there you go. So I'm going to go in y. Well, turn my calculator on. And in y, I'm going to put these two functions, the exponential decay function. So 236 times 0.881 to the power x. And x is right here. And then for the second function, I want to put the horizontal line. The horizontal line is just a linear function, a constant function. Y equals whatever that value you have. Y equals 95. So if I just graph this, I might not be able to see the graph because I need to set the window correctly. So this is where the domain, what x min and what x max should I put, and what y min and y max, what is for the range. So as you can see in here, for my y, if I want to see this entire graph, I should start somewhere above 236, right? And then for my x, I don't really know when this happens, but I can play around with x. Let's see. X is in 1971. Let's go up to 1990. So that means that I'll go for x from 0, 1971. Let's give it 15 years actually. So, and then for y, I need to go above 236. So let's go to 250. And then if I hit graph and I don't see the intersection point, then I need to rethink my x, because my x was just a guess. But I can clearly see the intersection point. So 15 years, looking over a 15-year period was enough. So to find the intersection point, and hence to find for what x, the y, the output is 95,000, I just click second and trace, which takes me to calculate, and I want to calculate the intersection, so I'm going to pick number 5. And when I hit enter, first curve, it's on the exponential highlighted right there, so I hit enter, I agree, and then the second the cursor moves on the horizontal line, I press enter again, and then I press another enter. And this is going to give me that the intersection point is 7.18. So after 7.18 years, the population of fish reaches 95,000. So this should be the answer, 7.18. So we have found that x equals 7.18. Estimate the year when the number of these fish reached 95,000. So the year 7.18, we're just going to approximate that 7 years, because if I round, it stays 7. So the year that the population reaches 95,000 is whatever 1971 is, plus 7, so it's going to be 1978. So the answer will be that. In 1978, the population of fish reached 95,000.